Hello and welcome to day 18 of the Advent of Code 2022. Today I will be something slightly different. For now I've been live recording myself while I solve the problems, but these last days I didn't have enough time, so I kind of hacked the solution in my spare time. And I will just now show you what solution I came up with. Today's problem was pretty easy compared to the couple days before. We got a list of cubes. Its cubes have a unit side, a side of 1 unit, and they are located in this 3D space with these coordinates, right? The first question is, what is the surface area of this scanned lava droplet? So this supposedly is a droplet of lava. This is the solution I came up with. So the first thing I did is create a set of the cubes. So I read all of the lines, I split them with the comma, and I convert them to an integer. Finally, I convert this to a tuple. It's important to use a tuple and not a list, so we can create a set of all these cubes. So we have a unique set of all of these cubes. One thing I did is take the minimum and maximum coordinate. So if you can, as you can see in this input, coordinates are not very big. You can see here there's a 20 and so on. With this, but they are mostly around a square. So it's mostly like a cube. So I just took the minimum and the maximum of all the coordinates across all the 3 axes, x, y, and z, and I took the minimum and the maximum by chaining with the itertools chain function all of the coordinates of all of the cubes. Okay. We will use this in the second part of the problem. So the first thing we need to do is know what is the surface area. We have these many directions. So each cube has 6 directions in which it has sides. So this is, let's say, left, right, top, bottom, front, and back. You could name these things different, but these are the 6 directions that the cube has. And then to find the neighbors, what you have to do is basically add to each coordinate. So this is a function that has 3 coordinates, x, y, z, which is a cube. And what are the neighbors of this cube? Well, it's basically each coordinate plus the difference in its direction for its dx, dy, dz in its direction. And what is the surface? Well, getting the surface is pretty easy now. All you have to do is do the following. Each cube usually has 6 sides. I mean, not usually. A cube has 6 sides. 6 sides. Each of these sides will be a surface if you don't have a cube in that direction. So what you can do is for each cube, we're going to count the surface of all the cubes. So you will have to do for each cube. We find all of the neighbors. So for n in neighbors of this cube. So now we have all of the neighbors of each cube. And ideally, these neighbors, which are 6, if all of the cubes were separated, you would have 6 per each node. So you would count just for each neighbor, which means one side. You have one neighbor per side. So for each neighbor, that is for each side, you have 1 square of surface area. However, you cannot count this neighbor if in this neighbor position there is a cube. So you just have to sum all of the neighbors which are not already in the cubes, so which are not already occupied. So this function computes the surface, and part 1, which means what is the surface area of your scanned lava droplet, you just need to count the surface, and here we have the solution. So this is the first part of the problem. Let's go for the second one. So the second one is interesting. What it says is, what is the exterior surface area of your scanned lava droplet? So apparently you have some, this droplet is a closed 3D object that may have some spaces inside where there are no cubes, but which we don't want to count as the surface. So what do we do? Well, here's where I take this minimum and maximum values for the axis, and I create a range from minimum -1, maximum +1, and I repeat 3 times. So here we will have x, y, z coordinates, and we create a set with all of these with all of these coordinates. What we would have here is just, supposing the minimum is 0, we would have coordinates -1, -1, -1, -1, -1, 0, -1, -1, 2, and so on. So to these coordinates, which is the set of this surrounding space, we remove the cubes. So now we have the space that is free. What we want to do is a BFS, a breadth first search. So we start from the boundary from outside of this space, and we want to visit all of the cubes that we can visit without getting into the cubes. For that, we will use this BFS algorithm. So we have a queue which uses a deck. The deck is something we will talk about here, but it is much faster than using a list because we want to remove the element from the left, this pop left. And if we did this with a list, well, we couldn't do this. This function doesn't exist for a list, but it could be slower. Using a deck makes this faster. So we start the search from this minimum coordinate that we know that is outside of all of the cubes because we took the minimum. Well, this is not right now that I think about it. I think we should take minimum -1, and I think here we could take maximum +2. I think that, sorry. I think if we don't do this, we could have some problems. So we take this minimum -1, minimum -1, minimum -1. And what we do is the following. While there are nodes to visit, so this queue is full, we pop left, we take the first element, and then if this cube C is in space, which means that that this is filled. Remember, we have removed all of these cubes from the space. So if this C, this cube that we have found, is free, we have been able to visit it, we can remove it from the space. So we remove it and we add all the neighbors of C to the queue. So what this will do is just basically visit all the possible nodes that it can reach, excluding the cubes which we have already removed from the space. What happens in the end is that space will just keep the space inside. So what will happen is that in the end, space only has the space inside this droplet. And so what we can do is calculate the surface of these cubes. This is an OR, but in case of set, this is a union. So if we make the union, we could write it here. Union of sets S1, S2 is S1 or S2. So if we make the union of cubes and the space, which will be only the space inside, then we have the droplet as a solid object and we can calculate the surface, and that way we find the solution. I wrote down some lessons that we learned here. We used a deck for a faster BFS. We used itertools.chain. So I'm just trying to list some interesting Python features that we used for solving this problem. We used itertools.chain to join all the coordinates in a single list. We used itertools.product to create this very simple representation of all the free space. Then we made the difference of sets S1, S2, S1 minus S2. So this is, here we use the set difference, here we use the set union. Then pop left is a simple way of taking the first element and just updating the queue. Then we used a very simple algorithm. So the easy way of finding the space inside was just creating the empty space around it and visiting all of the nodes outside. And then we needed to use tuples for this. This is important because you can only create sets of tuples. So this is something that we had to do. Well, this is all for today. I hope you enjoyed this video. This was a shorter video than usual. Just wanted to comment this solution. See you the next day.